Good morning, good afternoon, everybody. It is 11:01, so I am going to kickstart this panel. We have a very full agenda for today. And in front of you, you see the instruction slides. I see a lot of folks introducing themselves, which is fantastic. Please mute yourself if you can unmute. I don't think you can. And if you have any questions as we go through, please put it in the Q&A box and not the chat box. And we will be monitoring that and making sure that our panelists will respond to those when the time comes. My name is Eric Chu. I am an assistant professor in community and regional development in the Department of Human Ecology at UC Davis. And I am going to kickstart this panel with, if you will all indulge me, with a couple of slides just to get things going, just to maybe speak to the IPCC a little bit. I know you're all here to hear about all of our reflections on what the IPCC is about and initial reflections on the first working group report. And so we'll do that, and we will get to that as soon as we can. The IPCC, which I have the distinct pleasure of serving as a lead author in Working Group 2, which is the report that comes out early next year, is a global scientific organ that was established in 1988 to provide policymakers with relevant scientific and socioeconomic information assessment, scientific assessments related to global climate change. It's an expert synthesis of the best available science. But the IPCC cannot be policy prescriptive. And so we're all here to react to the first release of Working Group 1 report, which came out earlier in August. And the Working Group 1 report was actually part of a larger series of reports that you see listed here under the bullet points. And so there's quite a few portions to it. But today we're going to react and maybe speak to Working Group 1, all the different parts you see here down at the bottom. I have a hyperlink to everything, and so we might share the slides at the end of this today, so you can have a chance to look through it if you have not had a chance yet. And just so you know, the report, Working Group 1 is about the physical science basis. Working Group 2 is about impacts, vulnerability, adaptation. Working Group 3 is the mitigation chapter, the contribution. And Working Group 2 and Working Group 3 are slated to come out in February and maybe May, June next year. Next slide. Just a quick overview, and the panelists will speak a lot about this as well. Some of you may have come across the summary for policymakers document for Working Group 1. There's quite convoluted, dense scientific terminologies in there. And so great kudos to you if you were able to get through that. But one thing just to note as you're maybe going through it a little bit is some of the confidence and probability statements that are out there. And so I've just sort of screenshotted some of the figures and diagrams here just to let you know how some of these probability statements are created. And some of the reasons for why it's there. It's because it's a scientific assessment. It needs to provide traceable accounts and probability statements that talk about consequences that are very specifically targeted to decision makers. Hence, there's this sort of two-pronged approach to talking about probability. One is confidence. It's a qualitative metric based on how much scientists agree on a certain item. And so there's high agreement. There's a lot of robust evidence, the amount of literature supporting that statement that leads to high agreement, robust evidence. And then paired with that is a likelihood statement that is a quantitative probability statement that if you come across language in the summary that talks about very likely, uncertain, virtually certain, these actually have specific numeric probabilities attached to it. And you'll see those in front of you. And so as you're going through it, understanding qualitatively what the summary is about, what are the key messages, and they do a very good job, the IPCC does a very good job of highlighting some of those key statements. And when you're coming across the parentheses and there's high confidence, all that stuff, you get a sense of where sort of the assessment itself stands in terms of the robustness of the evidence. Hopefully I'm not saying too much that is off everybody's radars. Just a reminder of some of the main taglines, main key statements here from the Working Group 1 report. And this is the material that I'll ask the panelists to respond to for the rest of the panel today. But basically, the climate change is happening, unequivocal, human created, and the scale of change is unprecedented. What you see here is sort of the takeaway diagram of the change itself. And you see 5 scenarios in front of you in the graph here, ranging from if we go green today, the low end scenario, we're still looking at 1.4 degrees of change, global average mean temperature change by the end of this century, all the way to business as usual, which is about 4.5 degrees by 2100. So it's a lot of change. And in fact, the change between 1.5 and 2 can create a lot of differing impacts and risks from there. And we're actually built in, the system is built in with a lot of change already. And so I'll quickly, with the 5 minutes that I was given, sorry if that was a very quick overview, but just to get everybody everybody's minds in tune to some of the conversations that'll be going on. And so I'll turn to introducing our panelists today. I won't give bios right now, but just to show their faces, and I'll call on them as we go along. We have posed questions. I have posed questions to them so that they can respond to, and our esteemed panelists will have 1 minute to respond. And hopefully, I've posed 3 questions, and hopefully we'll go through that 20-30 minutes, and then after that, we'll turn to the audience Q&A. And so if everybody is online, can post their questions in the Q&A, that'd be fantastic. I will be, with other people's help, monitoring that. And so I'm going to turn off my share screen right now, and so that we can see each other. We can see the panelists. And if I can ask the panelists to maybe turn on their cameras. And so the first question I'll pose, given the slides, given the quick introductory remarks that I gave, is to Catherine Conlon, Professor Catherine Conlon. The first question is really kind of, given the materials that I've just presented, what are the main takeaways that you see based on your own research, your own work, and how has the science of climate change really changed between now and when the previous assessment report came out in 2013?
Thanks, Dr. Chu. So hi, everyone. I'm Katie Conlon. I'm an assistant professor of epidemiology in the School of Medicine and in the School of Veterinary Medicine. So my perspective comes from a very much a One Health perspective, right? So the intersection of human health, animal health, and environmental health. As an epidemiologist following and working on climate change for quite some time now, I think this report was really important to me because, well, it was impactful for me because we've been seeing the health impacts of climate change in the past. We know what's going to be coming. So the report itself didn't have many scientific surprises. We kind of anticipated what was stated, but what I think has been perhaps glanced over, because we know that impacts are going to be awful and very large without unabated impact or changes, is that we have a chance. From a 30,000-foot view of this report, it's easy to get stuck in the details and see the impacts as things that we can't avoid, but we can. We have an opportunity to limit the change where we are at right now. And so I like to think about it from that perspective, because I think otherwise it can be a little bit daunting. I'm not a climate scientist, so I'll let my colleagues explain how the science has changed, and that from the human health impacts perspective, we use a lot of that to help us with our science. So I am excited about hearing from my colleagues and their perspectives on this. But yeah, thanks, Dr. Chu. I appreciate your time.
Thanks. And next I'll call on Professor John Largier. Maybe same question. What do you think are the main key takeaways from that, the IPCC Working Group 1 report? You're muted, sorry.
Look at that, so eager. Yeah, good morning, everybody. Thanks very much. Good to be here. By way of introduction, I'm a an oceanographer focused on the coast and on estuaries, etc. Part of the Department of Environmental Science and Policy, and part of the Coastal and Marine Sciences Institute, as well as part of CARC, the Climate Adaptation Research Center. Yeah, as said, I mean, really there are no surprises, right? The ocean's getting warmer, has got and will get warmer. It has got and will get more acidic. It has got and will be less oxygenated. There's less sea ice, and with all of that, of course, the sea level is rising. So no surprises, but more precision, more certainty, and more things maybe we can really act on. Probably what is interesting, exciting is a new attention to events, because that's ultimately what matters, extreme events. Interesting seeing it as marine heat waves. There are a lot of other events which are kind of not shining attention on. It's not the average over time and space. It's short events and in local places sometimes. I mean, regions I'm talking about, not tiny places. And then thirdly, there's, I think, increased attention to compound events and sort of, you wouldn't call them cross-sector, but there's precipitation things mean a lot to the ocean. Low salinity events. We had zero salinity at Golden Gate Bridge in 2017. That did a number on the ecosystem. So things aren't separate, it's all connected. So 1 minute, right? I think that's enough for now. Thanks.
Great. Thanks, John. Maybe same question to Professor Mark Lebel. Maybe a 20-second intro of your own work, and then the same question.
Good morning, everybody. It's glad to see such a diverse audience at our discussion here. I am a social scientist who works on climate adaptation and decision making. So, I've got kind of an internal takeaway from the report, which is that there's been a lot of attention and change in terms of communicating the probabilities and how certain different types of things are going to be, and attributing climate change to human-caused, behavior. And I think that's gotten better over time, and paying more attention to how real people make decisions in that context. But the other thing, which I think is really even more important, is that we have climate change here right now, and when in terms of mitigating that, it's going to require unprecedented level of collective action, ranging from individuals to nations, to be able to do anything about it. And even if we reduce all carbon emissions to zero somehow magically right now as we're speaking, there's a lot of climate change effects are going to be locked in for decades, or even in the case of sea level rise, centuries. So we have a huge task in our hand. I am myself quite worried about our capacity to engage in that level of collective action, because it really hasn't happened at the level that's been needed yet, despite the increasing urgency every single IPCC report and the increasing evidence of it right here in our face, as all of us here in California are experiencing wildfire smoke, and folks in New Orleans are experiencing an insane hurricane. So things are happening. We need to act collectively. Thanks.
Thanks. Great. Next up, I'd like to call on Professor Helene Margolis. Maybe same intro, and then what are your main takeaways from the report?
Great. Thank you, Dr. Chu. So I'm an chronic disease and environmental epidemiologist, but started my academic life in marine sciences and oceanography. And so we have a convergence here. And much of my work is focused on climate change health impacts, including for the medically and socially vulnerable individuals. And in terms of this report, to reiterate what everyone has said, is that the evidence is even more robust now. There's literally no wiggle room. We have to act, and we have to act collectively now. Of particular relevance to my research is the greater attention in the report to the occurrence of compound events. That's when there's a combination of multiple drivers and or hazards that contribute to societal or environmental risk. And as an example, at the local and regional scale, concurrent heat waves and droughts that in turn contribute to occurrence of wildfires, which we're seeing. But at the global climate scale, droughts and heat waves in one food producing region and the floods in another food producing region, which they've shown are connected, or they're teleconnected in atmospheric processes, but that combined in those multiple regions pose risk to global food security. And so again, highlighting the interconnections between global to local health and society well-being.
Thanks. Next, Professor Erwan Monnier, same question. Intro, and then what are your main takeaways from the Working Group 1 report?
Thanks, Eric. Good morning, everyone. So I'm a climate scientist. I've been involved in the development of climate models, running climate models, using the output of climate models and observational data to understand climate change and its impact on society and the environment. So to me, this report, first of all, is quite incredible. It's a lot of work, and I would say there's two parts of the report. One, looking at the past, and really identifying the large changes that we have experienced, some of them being mentioned already, like the warming of the oceans, but also a capability to attribute some of those changes, in particular looking at extreme weather, to human activity, which is really an improvement upon the previous IPCC report, that now we're really able to tease out the role of humans in past extreme weather. And the other aspect of the report is looking into the future and seeing the potential worlds that we're going to live with or live in. And again, a major improvement is our ability to really look at the influence of future climate change under different scenarios, the role of humans and human behavior on extreme weather, and really adding a lot of confidence in our projection. And what I'll add is probably the final takeaway is, and that's been mentioned to some degree, is the window for action is closing. No matter what, I think we have built in a lot of climate change, a lot of impact that we're already feeling that will become worse, but that doesn't prevent us from trying our best to reduce these future changes. Thank you.
Thanks. And just to round out the panelists, Professor Fraser Schilling, same question. Main takeaways. Yeah.
Hi, thanks, Eric. I'm with Road Ecology Center, Director of Road Ecology Center at UC Davis, which is now affiliated with the Institute of Transportation Studies. And as both those names imply, I focus mostly on how transportation infrastructure interacts with the environment. And over the last 20 years, that conversation has fundamentally changed. That's reflected a little bit in the change between the 2014 AR5 IPCC report and the 2021 report. And a lot of that is a solidification of what previous panelists have mentioned, solidification of our modeling. I would call it, it's not really knowledge, but our projections for sea level rise and other changes, and our increasing confidence in what some of those might be. And one of the big changes over the last 7 years since the last report really speaks directly to the work I do with Caltrans and coastal agencies throughout the West and in Georgia, is when are things going to happen and how much is it going to happen? And although our certainty, the ranges of possibilities are still fairly wide, our confidence in our ability to model is definitely increasing or improving. The big uncertainties, the big things that are still unknown, even more emphasized in the AR6, the most recent report, is the role that sudden tilting points in glaciers and ice sheets are going to play in something like sea level rise. These are going to have reflective effects in ocean circulation and weather patterns, and they feed back obviously to each other. So as John Largier pointed out, these things are all related to each other. So there's still some big unknowns, but we're definitely improving our knowledge of what the changes are and are likely to be.
Thanks. Just to recap for those who are joining us, this is a panel, esteemed panel. We are reflecting on Working Group 1 report published by the IPCC, the Success Assessment Report, and we just chatted through the key messages. And the next question I want to pose is to the panelists is, where do we go from here? What do we need to do from a policy, from a community, from a scientific research perspective? What are the gaps that we need to start filling, and what are the opportunities for future action? I guess I'll start same with Katie Conlon. Yeah.
Oh, great, thanks. Well, I think that there's a lot that we can work on. One thing that I have been personally very interested in is trying to understand what efficient and effective interventions with the focus on health can be put into place. So I think that this report really calls that out, because we have to act soon, because we have to act yesterday. We really need to be smart with our time and our investments. So I expect to see that there will be a lot of research that's really focusing on implementation science and communications, kind of what Dr. LaBelle was talking about, getting more integrated research to answer questions about how to prioritize our interventions that can have co-benefits both for adapting and for mitigating.
Thanks. Next, I think is John. John, what do you think are sort of directions of future research inquiry?
Sure. So I think it's been stated, there's this very small window that is closing. In some ways, it's closed because back in the day, we used to think we could address this by emissions reduction, and those days are gone, particularly for the ocean. I think people recognize that there's a long game here, centuries and maybe millennia. So definitely my attention and attention of colleagues of mine is shifting much more towards adaptation. Like, what can we do about it so we're not harmed by it so badly at the same time as any emissions action? So I think that's a changing thing here. But part of that as well is that a lot of the ocean is not something that human management is going to do anything about. When it comes to acidification and deoxygenation, maybe we can reduce pollution stresses and it'll help. Sea level rise, maybe we can do some coastal management and it'll help. But there's a lot that's not going to help. So we really need to understand how is the ecosystem going to change, both for the feedbacks to the climate system, but also because those changes in the ecosystem ultimately will impact humans. And there's some big issues there, like what's the oxygen concentration on Earth going to be in a couple of centuries, to maybe smaller, but they're still big, like how many fish can we get out of the ocean sustainably? So that's, I think, is a big new focus. The other, I think I alluded to initially, is that we really need to start focusing on, it's almost like a risk assessment. What are the exposure to risk and what are the potential impacts? And that's not global systemic stuff. There's a lot of physical science required at a more regional scale. I mean, when you look at heating of the ocean, heating of the Earth, you don't see any sign of the upwelling systems where we're debating, are they warming up or cooling down? Because as the land warms more than the ocean, the winds get stronger, and the upwelling system, some of them, there's pretty good evidence that they are cooling and should be cooling, but you don't see that IPCC scale. So I'm not talking little stuff, I'm talking big regions. It's a challenge I'm sure they recognize, but clearly we need to push harder on that. Thanks.
Thanks, John. Erwan, same question. Where do we go from here?
Yeah, so I think in the last 10 years or so, there's been a major effort to improve on climate models, improve on their resolution, but in particular on running large ensemble of climate model simulation. That means running models under different scenarios of greenhouse gas emissions, representing different worlds and different level of mitigation. Also using different climate models to see whether there's agreement between climate models. But something that's been really new in the last 10 years is also running under what's called different initial conditions. That means that you start a climate model under very slightly different a starting point. And because the climate is chaotic in nature, you actually end up having different results. And by doing that systematically, we're able to understand the role of natural variability, different fluctuations in the climate system, and whether they play a role in our understanding of the future or future changes in the climate system. And really what we've seen is at the local scale, and in the short term, we talk about the next couple of decades, this natural variability, this natural fluctuations in the climate system really dominate and prevent really our ability to simulate accurately the future. So that has major implications for adaptation because of course, adaptation is done at the local level, and it requires knowledge about the kind of risk that society will be facing. And so this is, I think, an aspect of climate science and climate adaptation that will need to be really emphasized and focused on more, is understanding and translating this information of the role of natural processes, how they contaminate climate change, the signal of climate change, and what do we do about it when we want to adapt. Thank you.
Thanks. And next is Fraser. Yeah, what are some gaps and opportunities for future research?
Sure, thanks. Yeah, one thing that IPCC report does is it mentions likelihood and uncertainty a lot. It's you defined at the beginning, which is really useful. But one of the things that it doesn't necessarily do a great job at, and it's really limitations in our scientific knowledge and abilities, is to compound all of these things that are connected that we've all brought up now. They all have uncertainties associated with those, and they're feeding back with each other. So not only is the system complex, but there's a lot of uncertainty and unknowns about the complex system, which all compound and make our ability to project very difficult. So I want to point out a couple that I think we should focus on because of their impact, not and as the primary importance. So outlier possibilities, what is going to have the largest impact on societies? I think that needs to be in the front of our research chain, not looking at the median, but looking at the outliers. Shoreline impacts, which is what I study. And a lot of these have regional differences, and the regional differences in sea level rise is really where the adaptation and responses are going to be the most impacted. And so we need to look at how these regional changes are going to occur. And so we're informing people of change at the interface with decision-making at the appropriate scale. And also a lot of those shoreline systems, they're not going to linearly respond to something like sea level rise, just like wildfire probability doesn't linearly respond to fuel dryness and temperatures. And finally, there's going to be heat extremes like we've seen recently, which really let some genies out of the bottle. For example, in polar regions, heat extremes will cause massive melting. And when those reverse, it doesn't necessarily, not everything goes back in. And so these stochastic extreme events are going to push things further in an unreversible way. And so understanding those and what kind of impact those might have on us and on the ecosystems we rely upon, those also need to be at the front. So there's 3 things at the front of our list. Thanks.
Thanks. I'm going to turn to Helene next, but maybe ask Helene to also, in addition to talk about kind of what research should be done next, what are the gaps and opportunities on that front? Also sort of tag onto that question, practically, what does that mean for climate action in your domains? So what needs to happen in terms of interventions from a policy, from a perspective, from a community perspective? What needs to happen, when and where, to address some of these big trends that we're talking about?
Okay, great, thanks. So the add-on is actually a logical extension of some of the thoughts I had, which is going to the theme of compound events. So while AR6 has elevated the importance of quantifying the drivers and occurrence of the compound events, it's really focused on extreme events that co-occur in a relatively narrow time frame. And so one of the big things that comes up for me is what are the critical related to the interplay of these incident extreme events superimposed on residual or waning effects of prior extreme events, And those questions are of particular importance at the regional and local scales. As an example, the San Joaquin Valley combination of droughts and decades of unregulated groundwater withdrawal caused widespread aquifer system compaction and land subsidence. And those may not be reversible, even because of various precipitation, but also changes in soil structure and aquifer and groundwater aquifers. And so how do we need to understand that there's a temporal and a spatial component of this, and we need to downscale. And so that leads into that. And so understanding how these higher order climate changes are downscaling to the local level, and not just like California, but Sacramento or Fresno. So really understanding how there's this interplay, and then the things that we're doing at that local scale. The more impervious surfaces, the hotter it is, the greater the risk of flooding. And so I think that gets to that latter part of the question of adaptation and mitigation, and understanding those local scale processes and the feedbacks between higher and local. Does that answer the latter question? Okay.
Yeah. So I'll move on to Mark Lobel next, but maybe again, asking sort of the question of on the policy side, because you study that in institutions, what needs to happen, when and where, and sort of kind of building off of some of these big trends that we're talking about.
Yeah, so there was a question in the chat about what is the appropriate balance between mitigation and adaptation. And I actually think that is probably the biggest question that is facing us right now. I wrote a blog a long time ago. Now it actually got erased, unfortunately, on the UC Davis servers, because I had some good thoughts at the time. But the blog was entitled, How Do We Spend Our Climate Dollar? And if we have $1 of our kind of global budget to spend on climate change, how do we split that between climate change mitigation and adaptation? A lot of the discussion right now is almost like we have an infinite amount of money to do both adaptation and mitigation. And that's just not true. We actually don't spend a whole heck of a lot of our global budget, if you look, or our US budget on climate change mitigation or adaptation. So we have to think we have a limited budget. How do we split that between climate change mitigation and adaptation? And for me, the more that we see these extreme events and the lock-in that's happening, the more we need to think about shifting our money towards adaptation. And that is a politically difficult thing to say. There's a lot of resistance against that, but we really have to think seriously about that. And that doesn't mean spending no money on mitigation, but what is that fraction? And also recognizing that those are interdependent questions. So if we do some mitigation, spend some money on mitigation, that may reduce our costs of adaptation because there's less temperatures or less extreme events we have to deal with in the future. But that is a crucial thing. In my view, it hasn't really been studied very well, modeled very well, and there's certainly far from any sort of lack of political agreement on on the answer to that question.
Thanks. Maybe same question to Catherine Conlon. What needs to happen, and where and when?
Well, just coming from the health side of things. So I came from public health. I'm in public health. I think that there is a lot of work that's been done in public health to both adapt and mitigate to climate change. But as researchers in the academic space, what we tend to do is we go to the literature, right? We're going to the scientific journals and we're trying to find what's been published. I'm excited, and I would like to see more of interaction with our partners at very local levels, at city levels, neighborhood levels, state levels, that put science to practice, but they don't necessarily publish it. So in academics, we call this the gray literature. I think that there is a lot of opportunity here to translate these really wonderful studies that have been done but to practice. We have, by evidence in this part, in this webinar, a lot of people that are interested in how to take the findings of the IPCC report and make a difference and make change. I think that there's a lot of opportunity to kind of see what's already been done and what's being done and how to determine whether or not it's working or it's not working. So then we can prioritize our investments, as Dr. LaBelle said, so that maybe we can figure out ways to maximize co-benefits for adaptation and mitigation.
Thanks. And John Largier, what needs to happen, when and where?
I think I'll be very brief. It's sort of been said before, this is not just IPCC's issue, right? I mean, it's almost like a little bit of a top-down view of the world, and then we really need a bottom-up view of local, regional governments and groups to, like, what is it going to, where's it going to hit us, and then trying to work up and find a sort of shake hands with this very broad view. So that's what I think. That's what I'll say. I've said some other things earlier. Thanks.
Thanks. Erwan, what needs to happen?
So I think I'll echo a little bit about on what Mark said. When we look at mitigation, so the biggest uncertainty in our ability to predict future climate change in the long term is knowledge of the level of effort that society will put into mitigation. When we're looking at adaptation, we need to know what to adapt to, and therefore we need to know that level of mitigation in order to constrain our ability to adapt. And so there's really two worlds, right? There's a world where we essentially adapt with optimism to a 2-degree warming world. It would cost less, but it would require actual effort to mitigate and to meet the 2-degree target, which is obviously not a certainty. The other world is a world where we adapt to the worst, and we still mitigate quite heavily, and we are able to avoid the worst. Well, that's actually costly in both the mitigation aspect and the adaptation aspect. So what we really need is we need coordination of mitigation efforts and adaptation efforts. And that's really difficult because mitigation is really a global issue, requiring coordination by nations, governments, companies, and so forth. Adaptation is local, so that creates all sort of scale issues. And I'm not sure that we actually have the framework right now that is sufficient to address this dual issue. And I think we should invest more into understanding how to do those two, mitigation, adaptation, in coordination.
Great, thanks. And just a note of reminder for everybody logged on, if you have questions, please post on the Q&A link. We'll get to those after everybody's had a chance to respond to some of the prepared questions that I posed earlier to the panelists. And please do that, and we'll have a chance in a couple minutes to tackle those. And so I guess I'll turn to Helene next. What needs to happen? Same question as the others.
Okay. So, I mean, again, we have to take collective action now, punchline. And we need to advance adaptation science and develop these evidence-based strategies that integrate risk benefits of the strategies for mitigation and or adaptation. So basically co-benefits, but making sure that there's not leading into unintended adverse consequences towards the mitigation or adaptation. And the other punchline for me, and that needs to happen, is that as the COVID pandemic has hammered into us, the world and all its societies and peoples, we're all connected, interconnected. And so to ensure the health and well-being of the global community, climate actions must be predicated on also achieving sustainable global to local equity, because none of us will survive if we don't all survive.
Thanks. And Fraser, I think you get the last word on this particular question. What needs to happen?
Sure, great, thanks. And this is jumping a little past the WG1 report, but it is something that everybody wants to know. What should we do? And I want to point out, I want to push back a little bit on the mitigation versus adaptation. My research is primarily in adaptation. And I would say that that's just a constantly losing game without mitigation. You'll always be trying to catch up, and we'll always be experiencing economic losses as we do that. The business world is paying attention. There was an article in Forbes that quoted a recent scientific article on what's at stake. And just with current knowledge, there's about $24 trillion in assets at stake with current knowledge of before the end of the century impacts. So that's the size of our GDP. Our current annual losses due to events that are being exacerbated by climate change are on the same order of magnitude as estimates for the cost of mitigation. So we're at this balance point, right? And it really points to the need to ramp up our mitigation game. And I would just want to end with pushing back against net zero emissions, which has a solid foundation in the petrochemical industry and increasingly in government and NGOs, in that we can burn carbon now and then pay later, or my grandkids will pay later. I don't think that's acceptable. And probably half of scientists don't agree with that either. So I think we really need to evaluate what strategies we're looking at for mitigation as well, not just saying we're going to do mitigation later, doing mitigation now. And that means reducing carbon outputs now to reduce our economic losses, social losses, and ecological losses. Thanks.
Great, thanks. So maybe I'll turn to some of the Q&A, the cues that are coming in. But also maybe to preface that this panel we've organized, maybe I should have said this at the beginning, but this panel we organized quite in a compressed time frame to get this conversation in when the Working Group 1 report is fresh on people's minds, and with the intention that this will become a more regular thing as future Working Group reports come out as well. And so this is sort of just putting a stake in the ground and trying to get this conversation started, getting this network of folks out there to talk about what it means, because the IPCC reports are not meant to be policy prescriptive. It's just meant to be scientific assessment. And so again, please send your questions in. We have about 15, 17 minutes to take some audience questions. And I'm going to rely on Professor Michele Barbato to help me organize some of these questions, as I'm looking at multiple screens and I'm struggling to keep track with what's being asked. But maybe I'll pose the question that's right up top in the Q&A, which is about tipping points. I think, Erwan, you had wanted to say something about tipping points. A question from David Terpstra on tipping points. I've been reading some materials, methane release. Is there any credence to the speculation that has been circulating about large releases of methane at some point?
So yes, so there's a lot of methane that are stored in the permafrost in the Arctic region. There's also actually quite a bit of methane also stored in the Arctic seabed. And there's a lot of evidence of leaking methanes from Arctic lakes, of collapses of the permafrost, creating those sort of big holes that then get filled with water and then produce those bogs that can further release methane, and leaks from the seabed as well. There's tremendous amount of methane that's stored. The amount that actually can be released and how fast it can be released is something that is probably a current gap in our research. We know that it's thawing faster than we had expected, and I would argue there's a clear potential for additional greenhouse gas concentrations in the atmosphere because of this feedback. The level of confidence is low in our real knowledge of the total amount that could be released in the next 20 or 50 or even several centuries. But this is certainly a possible threat, and that needs to be researched further.
Thanks, everyone. Next question I see is from Kat Curlin. How can scientists better engage with and learn from communities most vulnerable to climate? And I'll call on maybe Katie Conlon to address that.
Thanks. I think this is such a great question. One of the things that when I'm working with students to train them to become better climate adaptation practitioners is to think about the communities that they're going to be working with. Oftentimes we come up with these great ideas on I think about things in terms of interventions, how we can intervene to protect populations, specifically those who are most vulnerable. But what we sometimes fail to do, and I think we've seen this in the example of COVID, is not think about what we call the readiness of the population that we're working with. So the readiness for that population or that community to uptake the intervention, to change their behaviors. So with that in mind, I think what's most important is to really try to understand the community that you're talking about. We have so much that we can learn from our native populations, communities in the United States, especially around fire and how to manage it, for instance. If you want to take a look at Hurricane Ida right now, I think that there's a very interesting discussion that's happening nationally asking, why do communities along the coast stay there? Why do they rebuild? I would ask people to start thinking about, what is it about that community that really encourages them to stay there? Is it because they might not have the resources to live? Is part of their identity attached to it? So really coming at this from a very thoughtful and intentional perspective, because if we want to have change, and which we do, and it revolves on or relies heavily on collective action, we really have to be considerate of the populations that we work with, so that when we suggest change or try change, it's really thought out and thoughtful. So thanks for that great question. I don't know if others have anything they want to jump in on quickly.
Thanks, Kate. I see, Mark, you're typing an answer to that same question. Did you have something to add, or?
Well, I can say it. I work a lot with local communities in the context of sea level rise, especially Bay Adapt's joint platform on sea level rise for sea level rise adaptation in San Francisco Bay Area with Bay Conservation Development Commission. And I see a lot of BCDC people on this call in the chat. So hi, everybody. It's really a crucial environmental justice issue. There's a lot of disadvantaged communities that are not only more vulnerable to climate change, but they also have a lower adaptive capacity. And as a result of socioeconomic differences, structural racism, a long history of those disadvantages that have piled up on them. And they're also more vulnerable to things like COVID, housing crisis. It all kind of intersects and it makes it very difficult. So you have to appreciate their local knowledge. You have to engage with them early. It's really important to have in-person relationships with community members, not just like adding distance through a web portal. You got to develop that trust. It takes quite a long time. You shouldn't be treating all the environmental justice communities as one block. Oh, here's the EJ communities. There's no difference between them. They have lots of differences between them, different local circumstances that they have to deal with. They all need help with money. They constantly get asked to participate in things with not enough compensation, and they have limited resources for doing so. So it's important to help to fund them to participate and help them get engaged. Those are all some of the lessons that I've learned in working with Bay Adapt. It's an incredibly important issue, and also I think one of the more difficult issues and challenges we have to face with climate change adaptation.
Thanks, Mark. John, did you have a specific point about this particular question as well?
Yeah, first to reiterate what Dr. Conlon and LaBelle said, not reiterate, just re-emphasize. But the point I was trying to make earlier, I think, is exactly this, is that if we're talking about IPCC, is not the only game in town. In actual fact, it's maybe a little bit of an old-fashioned science game. I'm remembering when we designed marine protected areas for California, when the scientists tried to do it, it didn't work very well. So we really need to start as climate change at both ends, and it needs to be a dialogue. What are the impacts? What are the concerns? What are the high priority things? And then work back up the kind of causal chain to this systemic IPCC view of the world. Is it very different? How do you do that is another question, but it'd be really nice to see IPCC kind of try and make that engagement. Thank you.
Thanks, John. I think Helene, you wanted to say something
Yes.
about this community
So,
question as well. Yeah.
Yes, thank you. So all of what my colleagues said is just spot on, and I just cannot understate the importance of co-creating interventions and co-creating knowledge, working with communities, but having that trust, but also really understanding how to work with them. And it isn't just language translation, it's all of the cultural translation and cultural humility. And within that, it's that interface between government. A lot of times local government's viewed as the adversary, as we've seen with public health people being threatened because they want masks. And so helping, we as scientists and as practitioners can help bridge those interfaces in multiple directions. And so I think that's one of the keys, is to walk with humility with whomever we're working with.
Great, thanks, Celine. We have a question here, building off Eileen's point about local governments, from Sadie Wilson. What is the most impactful action local governments, cities and counties can take in terms of adaptation? How can land use planning be used to take swift action, especially in the context of existing housing pressure? And I will turn to Fraser to maybe give a first response to that.
Sure, and I'm gonna attach it to another question. How can state and local governments be better able to use laws and regulations to improve local adaptation? And this is something that local governments are really struggling with, not only the regulatory part, but also the funding side of it. And I think the first thing that you can do is first do no more harm, right? And I think the Coastal Commission is setting the stage for that with really putting pressure on the permitting process. And the local governments can do the same thing. That's their power. They have that power to reduce the new developments into areas that will be impacted, that are likely to be impacted. And so that would be the first thing, and therefore it will have the most impact in at-risk coastal areas. The next thing is for the local governments to work with the state to come up with legislative packages that really gives them the power to make these changes and really start pushing back the edge of communities away from the risk areas, which will require things like property taking or rezoning and so forth, things that people aren't going to like. But the alternative is going to be very big expenses. So but the legislature really needs to back up the state government in this way and collaborate with them on what those regulatory powers can look like through their land use powers.
Thanks. I think, Helene, you mentioned, I think you said you had a response to that, and then maybe I'll turn to Mark also after you to, I think he had some points also.
So one of the things that's really important, regardless which government level we're at and which jurisdiction, there has to be a multi-sector discussion. And adaptation by one sector can have adverse consequences on other sectors. So energy policy can have trickle down on health. And in fact, most of these have trickled down on health. But so energy and housing, where we place housing, and it has to, they're just that multi-sector discussion. And not just discussion, but really quantitative evaluation of, if a given strategy is adopted by one sector, how might it affect other sectors? And I think that's where some of the skill sets that, like the Adaptation Center has, where we can integrate that knowledge, because that is not off the internet type of assessment. And so that is, I think that's what local governments and state governments could do, is, really working together that way.
Thanks. Mark, did you have an addition to Helene's input, or?
I think I answered that one in chat. All right.
In chat. Okay.
Yeah, thanks.
Sounds great. And so thanks. I have a next question on any recommendations for leading sources of online information for planners who can use that for adaptation studies locally. This is a question specifically about transportation, possibly. And so maybe Fraser, thoughts on that? Yeah.
Yeah, there's not a lot of good organized literature like that. And there really needs to be a central clearinghouse. I know Federal Highways has an initiative that has resulted in collection of information, Federal Highway Administration collection of information that could be used in this way. I'm not sure there's a case study kind of library. I think there are case studies in their collection of information, but there's big gaps. So I think it's a growing area, and I would just keep your Google search engine going on that one.
Can I just jump in real quickly? There
Yes,
are
Kate.
some adaptation warehouses. The Georgetown Climate Center has one. There's one that's there are a handful available. So I actually have a list of this. If you're interested in climate health interventions that have worked, CDC has done a report it's a little bit older now, but that's available. I'm happy to share that at the end of once we share all of our resources. But there are some, and I think that they're growing, which is great. So that all of you all who are doing this, you can also add to them.
Great, thanks. I see a lot of questions. I'll just pick one last question, and then the rest we'll distribute amongst the panelists and have them respond separately. I appreciate everybody for posing questions. We have 3 minutes left, and so we'll do our best. And the last question I'll pose is maybe something on, can a panelist talk about the potential of natural engineered carbon renewal and sequestration technologies and alleviating impacts? So maybe a geoengineering question. Erwan, yes.
Yeah, so I'll just mention very briefly that when we talked about the different futures and looking, if you had a chance to look at the IPCC report, there's different scenarios. Well, the scenarios to really limit warming to under 2 degrees are relying on both natural solutions. That means carbon sequestration to the land through reforestation, massive reforestation, as well as carbon removal and sequestration. They essentially require negative emissions of carbon within the second half of the century. That means that instead of emitting carbon into the atmosphere as a society, the world is actually sequestering as a net carbon and removing it. It starts to removing it, and this has to be scaled massively. So there is potential, but we're dealing with first of all technology that has not been shown to be scaled, at least not yet, especially when we talked about carbon removal, sequestration, engineered. And in terms of natural ways, well, there are some questions about, if we reforest massively, given the kind of wildfires we're experiencing in the West, are we going to just have forests all over the world that are going to be on fire, which will not help? So there's a lot of question marks. A lot of the models and the modeling groups that are simulating or simulating these kind of scenarios are making assumptions that are generally very optimistic about the potential for success of these technologies or these solutions.
Thank you all. I'm going to actually close here. It's 11:59. I just want to thank the panelists for a wonderful discussion. Hopefully that wasn't too quick. I know I tried to move everybody along very quickly, knowing that there are a lot of questions being posed. We have collected those questions from the participants, and we will try to respond to those separately as much as we can. Lastly, just a plug for our work here at UC Davis and the Climate Adaptation Research Center. Again, our intention is to hold more of these conversations going forward, especially now that there's a more or less fixed timeline for when the next working group reports from the IPCC are coming out in the sixth assessment cycle. And so please do keep an eye out on those, and with our websites and our social media and all that. And also to thank all of our participants for being here, for spending this hour with us. Really appreciate your coming on board and interacting with us. So thank you again. And I will close this panel. Thank you.
Thanks, folks.
Thank